All right, here's the FRQ that we worked on, and this is going to serve as an answer key. So after you read the problem, the first question asks, determine the mass in grams of carbon in 1.2359 grams sample of this compound. So it tells you that we had 2.241 grams of CO2. And we're going to do this just the way we did before. First, changing grams of carbon dioxide to moles of carbon dioxide. And then we're going to pull the carbon out of the carbon dioxide, and the answer will be 0.05092 moles of carbon. If you went straight to grams, that's fine. You just need to have one more conversion factor where you multiplied by the molar mass. But I know I'm going to need grams and moles, so this is going to be 0.6115 grams of carbon. That's the answer to the first question. Second one asks, when the compound is analyzed for nitrogen content only, the mass percent of nitrogen is found to be 28.84%. Determine the mass in grams of nitrogen in the original 1.2359 gram sample of the compound. So I started off with 1.2359 grams of the sample. Now, this time I'm going to use the percent, 28.84%. We turned it into a percent by multiplying by 100. So 28.84% as a decimal is 0.2884. It's got to move that decimal point back to turn it from a percent back to a decimal. And I get an answer of 0.3564 grams of nitrogen. Next one says, determine the mass in grams of the oxygen in the original sample. Well, the original sample had a mass of 1.2359 grams. Let's subtract off the carbon that we calculated. Subtract off the nitrogen that we calculated. And subtract off the hydrogen that they gave us in the problem, 0.06480. And all that's left over, because you can see it contains only carbon, hydrogen, nitrogen, and oxygen. When you take the whole sample, which is all of those together, carbon, nitrogen, hydrogen, and oxygen, if you take this and subtract off the carbon, hydrogen, nitrogen, you will end up with the oxygen, which in this case would be 0.2032 grams of oxygen. Now remember, I said we're going to need both moles and grams. So we'll take the grams and divide by 14.01, which is the molar mass. And I'll get point, and we're going to use this for the last part. So we have 0.02544 moles of nitrogen. We have from the first part, 0.05092 moles of carbon. We have 0.06429 moles of hydrogen. They gave us grams in the problem, so we just changed that to moles. And then we have 0.01270 moles of oxygen, which I got from this last part. So now we're going to compare by dividing by picking the smallest number, 0.01270, and dividing each of these by this. And that gives us for nitrogen a 1, for carbon a 5, for hydrogen a 4, for oxygen a 2. So my empirical formula is C5H4NO2. And I know the question is always, does it matter which order I write them in? And the answer is not necessarily. So my go-to in these to write them in the order they're given to us in the problem.